Welcome to the AI lecture series. In this lecture we will have a brief discussion about the intelligent agents. So in today's lecture we are discussing agents and environments, the concept of rationality, the nature of environments, and the properties of task environments. So let's start our lecture. So an agent is in anything that can be viewed as perceiving its environment through sensors which act upon that environment through actuators. The simple idea is illustrated in figure. So if we call a human an agent, so a human agent has eyes, ears, and other organs for sensors, and the hands, legs, vocal tract, and so forth. These are for the actuators. So the figure shows how agents interact with environments with the help of sensors and actuators. So the sensors, they are used for the input data. They collect information, signals, and agent, after collecting information or signal to sensors, it then proceed or process the input information, and the actuators, they are used to perform certain actions. So all is done with the help of sensors, actuators. The actions are performed through actuators and the perception is done through the sensors. So agents interact with the environment with the help of sensors and actuators. So a robotic agent might have cameras. If you take a robot as an agent, so it might have cameras and infrared range finders for sensors and various motors for actuators. So with the help of cameras we can receive input data, and with the help of motors we can perform certain tasks or actions. So a software agent, it receives keystrokes, the file contents and network packets as sensory input, and acts on the environment by displacing on the screen. So it may be writing files or it may be sending network packets. So how the agent behavior is described? An agent behavior is described by the agent function that maps any given perceived sequence to an action. So the agent function maps any given perceived sequence to an action. Also the agent function for an artificial agent will be implemented by an agent program. So we have agent functions and agent programs for certain actions and perceptions. So there is another example for the agent and environment. There is a vacuum cleaner example. This particular word has just two locations. One is square A and the other is square B. The vacuum agent perceives which square it is in and whether there is dirt in the square. So it can choose to move left, move right, suck up the dirt or do nothing. So the vacuum cleaner performs certain tasks. It can move to left or right. It can perform the cleaning or it do nothing. So one very simple agent function is the following. If the current square is dirty, then perform the cleaning task. otherwise move to the other square. So figure 2.2 show a vacuum cleaner world with just two locations. Location A, it has dirt in it, while location B, it also have dirt. So the task of the vacuum cleaner is to sense the dirt and perform cleaning, whether it is section A, square A, or whether it is section or square B. So wherever it finds the dirt, it will perform the cleaning task, and if there is no dirt, then it will perform no task. So figure 2.3 shows a simple agent function for the vacuum cleaner function. So if there is dirt, it will perform the task of cleaning, and it can move to right if there is dirt, so perform the cleaning. It can move to left, and if there is dirt, so it will perform cleaning. So in this way the vacuum cleaner will perform the task in the form of perceptions and actions. So what is a good behavior? We will explain in the sense of the concept of rationality. So a rational agent is one that does the right thing. So conceptually speaking, every entry in the table for the agent function is filled out correctly in the previous figure. So obviously doing the right thing is better than doing the wrong thing. But what does it mean to do the right thing? How an agent will be guided to perform a right thing or right task or right instruction or sequence of process. So when an agent is plunked down in an environment, it generates a sequence of actions according to the percept it received. So in this way, the agent is trained to perform the right task. So the actions that are generated according to the percepts which are received to the environment. So in this way the agent is guided, or an agent is trained to perform the right task. So the sequence of actions which are caused by the environment to go through a sequence of states. If the sequence is desirable, then the agent has performed well. So this notion of desirability is captured by a performance measure. So a performance measure evaluates any given sequence of environment states. So what is rational at any given time? It is dependent on four things. The performance measure that defines the criteria of success, the agent's prior knowledge of the environment, the actions that the agent can perform, and the agent's percept sequence to date. So this leads to a definition of a rational agent. So these four things or parameters or features, they are measured, or their performance is measured through these criterions, and these criterions are known as the criterion of success. Now discussing the nature of environment. So if we are designing an agent, the first step must always be to specify the task environment as fully as possible. We have to specify the task environment, what actions, what perceptions should be performed, what actions should be taken, and what process should be done in that environment. So the economically minded, we call this the performance environment actuators and sensor description, which is known as PEAS. So in the next figure we will summarize the PEAS description for the example of a taxi task environment. So the example of taxi environment, the agent type is the taxi driver. So the performance are measured for different criterions. It is safe, fast, legal, comfortable trip, the maximization of the profit. These are the performance measures. So what is the environment? The given environment for this taxi example is roads, the air traffic, the pedestrians, the customers, all are the environment that is provided for this example. What are the actuators? Steering, accelerator, brake, signal, horn, display, all these components are the actuators which will perform certain tasks or actions. And the sensor are the cameras, the speedometer, the GPS, the accelerometer, engine sensor, all the type, all these component types which send data or signals to the car. These are all related to these sensors. So this is a common example of PEAS description. We have a lot more examples to describe the PEAS system, the performance environment actuator and sensor description for a given example or given environment which performing several type of tasks. So what are the properties of that task environments? So the range of task environments that might arise in AI, it's obviously vast, but we can identify a fairly small number of dimensions along which task environments can be categorized. So these dimensions determine to a large extent the appropriate agent design and the applicability of each of the principal families of techniques for agent implementations. So the properties which identify a fairly small number of dimensions through which the environments can be categorized. So these properties can be determined, explained, and they are dependent on the task environments. So we have several properties. The first one is fully observable and partially observable. So how we can differentiate between fully observable and partially observable? If an agent sensor gives it access to the complete state of the environment at each point in time, we can say that the task environment is fully observable. A task environment is effectively fully observable if the sensors detect all aspects that are relevant to the choice of actions. Relevance in turn depends on the performance measures. So the fully observable environments are convenient because the agent need not maintain any internal state to keep track of the world. The second one is single agent versus multi-agent. The distinction between single agent and multi-agent environments may seem simple enough. So the agent solving a crossword puzzle by itself, it is clearly in a single agent environment, whereas an agent playing chess is in a two-agent environment. So the task which is performed by a single agent individually in a given environment, it will be a single agent, and the tasks which are performed by more than one agent, They are categorized in multi-agent types. The other one is deterministic and stochastic. If the next state of the environment is completely determined by the current state and the action executed by the agent, then we say that the environment is deterministic, otherwise it is stochastic. Episodic and sequential. If an episodic task environment, the agent's experience is divided into atomic episodes, so it will be an episodic agent. So in each episode, the agent receives a percept and then performs a single action. Crucially, the next episode does not depend on the actions taken in previous episodes. So it is not dependent on the previous episode. The next episode will not be dependent on the previous episode. While in sequential environment, the current decision could affect all future decisions. So we can say that the future decisions are dependent on the current decisions, or future actions are dependent on the current actions. Static and dynamic. So static and dynamic can be explained, and if the environment can change while an agent is deliberating, then we say that the environment is dynamic. For that agent, otherwise it will be static. The static environments are easy to deal with because the agent need not keep looking at the world while it is deciding on an action. So it will not be worried about the passage of time. While the dynamic environments, on the other hand, are continuously asking the agent what it wants to do. If it hasn't decided yet, then counts as deciding to do nothing. So we can say that the static are the stable one, while the dynamic are the changeable, or they are changing their state. Discrete and continuous. The discrete continuous distinction applies to the state of the environment, to the way time is handled, and to percepts and actions of the agent. So the chess example for a given environment has a finite number of distinct states. The chess has also a discrete set of percepts and actions, while the taxi driving is a continuous state and continuous time problem. The speed, the location of the taxi and of the other vehicle sweep through a range of continuous values and do so smoothly over time. So the discretized or continuous distinction, these are applied to the state of the environment, and they are concerned with the state of the environment. Known versus the unknown. These two are linked or related to the agent's state of the knowledge, and that knowledge is about the laws of the science. We can say the laws of physics of the environment. So in a known environment, the outcomes for all actions are given, and obviously if the environment is unknown, the agent will have to learn how it works in order to make good decisions. So the known agent will have the, we can say, basic knowledge of the given environment, while the unknown will learn through the environment. So we have discussed the agent and environments in detail, how agents are linked with the environments, and how the actions and perceptions, through perceptions the actions are being executed, how the sensors and actuator works in a given environment. So thanks for your time and consideration.